Okay, we're going to talk a little bit about fractions, and I know that a lot of you may know fractions really well, and some of you may not. So, if you are one of those people that understand fractions and need to not watch this video, that is totally fine. But some of you guys might struggle with them a little bit, and I'm going to start with comparing fractions and basically what type of fractions are out there. So, to start with, um, breaking and dividing, results of breaking and dividing, why do we need to know fractions? Well, a lot of times in pharmacy, we look at like a proportion of a medication. So a lot of times when we look at a portion or a ratio, we're really looking at a fraction of medicine, like amount of fraction of an active ingredients compared to everything else. So first of all, let's talk about what a common fraction is. And a common fraction, here is an example of a common fraction. It has a number that's usually smaller over a number that's usually larger. Okay, and the top number is referred to as the numerator, and the bottom number is referred to as the denominator. And the numerator is part, and the denominator is whole. So I put a couple circles here, and this is just like a piece of a pizza pie. So I love pizza and I want a large slice of pizza. So if I have these two pizza pies and they are both the same size, I am going to cut this one like this, and this one is going to be cut like this. Let's see if I can do this. Okay, so this one is 1, 2, 3, 4, and I want one piece of pizza. So it's this part here I take out, that's 1/4, right? Where this one, if I take this pizza pie out, I get 1 out of 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, so obviously looking at this, this is my numerator, which is the part, and this is the whole. Let's say I take 2 of these, so that would be 2/8. Okay, and that's basically the common fraction that I wanted to talk about, so you guys kind of understand that. Now, what other type of fractions are there? So let's look up here is you have your, here this is for another class. So simple fractions, which when we looked at this number here, 2/8, if we had 2/8, we can simplify this to be equivalent to 1/4, and that's the simple fraction. A compound fraction is usually necessary for either the numerator or number, such as like having like 2 times 4/12. That's a compound fraction. You can actually solve that, so 2 times 4 is 8/12. That's what it's basically saying. So it's putting an algebraic equation inside of your fraction. Which we would probably never really use in pharmacy. So I'm not too worried about that. So a complex fraction is, it has a simple fraction with a numerator and denominator or both. So here we wouldn't see this very often in pharmacy, but if we did, it would be 1 1/2. That's our numerator over 6, which to me, the best way to solve this would to make that 1 1/2 into a decimal. So, and it'd be 1.5/6. So that's a complex fraction. We don't see that very often either. A proper fraction is the numerator is smaller than the denominator. So you have 6/8 or 4/5. This is common. So we are used to proper fraction, and we're also used to improper fraction, where the numerator is larger than the denominator. So here you have 16/4 or 15 over 3. Um, Now, these improper fractions can be converted into mixed numbers, which typically that's what we work with in pharmacy over improper fractions. And to do that, to convert an improper fraction into a mixed number, is what you do is you take 4, your denominator, and divide it by the numerator. So 4 goes into 16 4 times. So if I make this improper fraction into a mixed number, the answer is actually 4. Or here, this is 3 goes into 15, which I'm not sure why I made them so simple. That goes in there 5 times. So this mixed number would be 5. There's no fraction in it. Let me think of one that's completely different. Let's do 29 over 3. Okay, I don't know if this is going to work, but 3 goes into 29. 3 goes into 29. Let's say 9 times. 9 is 27, and that ends up to be a 2. So it would be 9 2/3, and that would be your mixed number for that, because you take this number and you put it here, and you take this number and you put it there. So that's how you convert an improper fraction into a mixed number. Now, how do we go from a mixed number to an improper fraction? You take this number and you multiply it by this number. So 3 times 2 is 6, and you add the numerator, which is 1, so it'd be 7, and then you go back to the denominator 2. So that's your improper fraction conversion. So you guys are going to get a little practice on that. Can you guys see that? Okay, so let's do 5, this one here, how to convert that into an improper fraction. Let me pull this down so you guys can see it a little bit better. 5 1/2, we want to make that an improper fraction. So 2 times 5 is 10. That's 10 plus 1 is 11 over your denominator, which is 2. So it's 11 over 2. And that's how you convert the mixed numbers into an improper fraction. Now to go back to the mixed number, you would do 11 divided by 2, and 2 goes into 11 5 times. 5 times 2 is 10, and that's 1, so it'd be 5 1/2. And that's it. Okay, so I am not too worried about you knowing compound or complex fractions. Those are just really definitions, but I do want you to understand how to move between improper and proper mixed numbers. And then the next thing I want to look at is equivalent fractions. How do you know if a fraction is equivalent with another fraction or not? So let's take a look at that. So this is a very simple way to figure this out. Okay, so these are simple. We know that 1/2 and 2/4 are equivalent. You can look at that and you know that because you can simplify 2/4 into 1/2. Same here. 3/5 is equivalent to 15/25. So you can see that, if you simplify 15, 5, is 3, and 5 here is 5, so it's 3/5. So it's very simple to see that these are equivalent. But if you're working with a larger fraction, sometimes it's really hard to see. And the one way you can determine if a fraction is equivalent, meaning they're going to equal each other, is this equation here. So let's say these are our fractions. A over B equals C over D. How do you know A over B is equal to C over D? Basically, you want to take A times D, so the numerator of the first fraction times the denominator of the second fraction, and should be equal to the denominator of the first fraction times the numerator of the second fraction. So let's take an example here. Let's think of 3/4 is equivalent or not to 9/12? That's the question. So 3 times 12 is what? 3 times 12 is 36, right? Is that equivalent to 4 times 9? 4 times 9 is 36. So we know that those fractions are equivalent. So this is equivalent. Let's try another one. Let's say 2/3. Is that equivalent to 4/16? Okay. So 2, can you see here? I got to make sure I'm staying in my screen. Oops. 2 times 16 equals, what would that be? 32. And 3 times 4 is equal to 12. So those do not match, so I can say this is not equivalent. And that's how you can determine if a fraction is equivalent to each other. So that's how you tell equivalency. So I want you to write this equation down right here. And I want you to save it in your notes because you're going to use it on your practice questions. And I want to make sure you guys understand how to figure that out. Okay? Now, when comparing fractions to determine which one is bigger or not, if the numerator is the same, the fraction with the smaller denominator has a larger value. So remember that. The fraction with the smaller denominator has a larger value. That's if the numerator is the same. So here we have the same numerator, which is 1. So the one with the larger value is smaller. And think about this. If I made this into a piece of pie, this is 1/4, and this is 1/6, 1, 2, 3, 4, 5, 6. Obviously, this piece here, this one piece, is going to be bigger than this piece. So remember, the one with the larger denominator is smaller than the larger. Okay? So 4 is smaller than 6, so this makes it smaller. It's a little confusing when you think about it that way, but try and remember that. Now, looking at something with the same denominator, the fraction with the larger numerator is larger. So here, the numerator, whatever number is larger, makes that fraction larger if the denominators match. Okay, so these are 2 rules you just kind of need to remember. Okay, so I would write these down in your notes so you have them and you can refer back to them. So let's apply this. So you're like, why do I need to know this? Like, what's the purpose? So let's take a look at a medication, nitroglycerin tablet, and these are some dosing of nitroglycerin, 3/10 milligrams per tablet, 4/10 milligrams per tablet, and 6/10 milligrams per tablet. So my question is, which one of these is the smallest? Well, they all have the same denominator. So what was the rule again? Let's go back to our rules. If they have the same denominator, the fraction with the larger numerator has the larger value. So whichever numerator is largest here is the largest value. So this one would be your smallest, and that's what the question asks. So the correct answer is 3/10 because that's your smallest dose. So remember, let's do it like this. What if we had these 3 fractions? 1 and 2/100, let's say grain. It's a way we measure. We'll talk about that more. 1 and 1/5 1 and 150 grain, or 1 and 100 grain. Okay, so which one of these tablets is the largest dose? So remember, all the numerators are the same. So whichever denominator is the smallest value is the largest dose. Isn't that what the rule says? So let's look back here. Same numerator, the fraction with the smallest denominator has the largest value. So which one of these would be the largest? This one has the smallest denominator, so this would be the largest, and this would be the smallest. Okay, so that is equivalence and a little bit about fractions. So I'm going to have you guys go ahead and take a little quiz on these so you can understand them.